Sleep. Okay. Feeling rested because you're here. Usually by the end of the day, I don't have many people coming in because they're tired. They're really tired. Sitting in front of the computer, right? How about you, Christian? You okay? You sleeping okay? His microphone's not working, so he probably doesn't even hear me. Maybe he needs to see if they have a trouble because sometimes they just don't reboot. Well, you're the only person here today, Ariana. Well, that's something. I have had some people, getting less and less. So we got like a month until spring break. Can you believe it? Spring break, just before Easter. You gonna go anywhere, or are you gonna just stay home? Hey, Lennon. Anybody have any plans for going for on spring break in a month? I think I might go to Chicago. Yeah, we're gonna do that the last half hour, okay? Hey, Joey, how are you? Yeah, I'll leave you a link. All right, sounds good. All right, thanks for coming in, guys. We are gonna have a we're going to collect names of people that are participating. We're going to have a drawing on Friday, and it looks like you guys are the only 3 people here. So again, it would be a small drawing. So what's a force? So that's what we're going to be talking about today. 10 different forces and types, fundamental forces. So we're going to be talking about those. And we're going to be talking about forces and pushing and pulling and so forth like that for the next 4 weeks. So this is the introduction to that. All right. So what is a force? Anybody got an idea what a force is? Let me have you ask. I'm going to ask that question. It's a 4-letter word, starts with a P. All right. So what is a force? All right. What is a force? What do you think? What do you think? In your own words, what do you think? It starts with a P. All right. Start a poll. What do you think? When you think of a force. Okay, that's a cool one. Yep, we're going to be talking about that later on for sure. Anybody else? Thanks, Lennon. I appreciate that. All right. All right. Yep, you do have to do that as well, Ariana. Thanks. How about you, Joey? What do you think a force is? So far we got you got to be physical to have a force, right? And you got to have power. There you go. Hey, Joey, I think you watched the video yesterday. Good for you. Yeah, it's a force is a push or pull. All right, acting on an object. It's a vector, right? It has both magnitude and direction, right? Up, down, right, left, plus, minus, north, south, east, west. Hey, Zaria. So we have 2 different kinds of forces, contact forces and non-contact forces. So contact is directly touching things, right? So like um, if you grab something, there you're touching it, you're throwing it across the room, you're touching it, right? And there's non-contact forces, which are like magnetism, right? Where there's a field. You can see the influence of a magnet on a piece of metal far away before it touches, right? Sorry, guys. And then there's also gravity. We don't, we're being pulled to the ground. We're staying here, right? Because we know that in space there is no gravity, and unless you're on some kind of planet. And then there's also electrostatic force, where you rub your hair against a balloon and you can stick it against the wall. So you can see the effects of those kinds of fields. So the types of forces are about 10 of them. There's more than 10, but we're going to just talk about 10. The applied forces, gravitational forces, frictional forces, centripetal forces, tension, And this is not tension that you get from a headache, but it does, tension can cause a headache. Normal forces, magnetism, and electrostatic forces. And then there's also some nuclear forces which are inside the atom. Many more, but there are about 10 that we're going to be talking about. All right, so applied force is equal to anything that you can directly apply. Like if you think of an application, you're applying paint, right? You're actually doing something. But in this particular case, if you like to play pool and you take a ball, you hit the cue ball, right? Bang, and it'll knock into another ball. So you apply the force to one ball, but it hits another ball. In my case, it usually doesn't. And then you get an applied force. Example is a push or pull directly on an object, right? Hey, who else did we get in here? Oh, wait, let's say Jasmine. Hey, Jasmine, how are you? Oh, Ariana came back. She had to go in and out. All right, and so one of the interesting things about the forces that are surrounding us is the gravitational forces. It's the force of attraction between all objects in the universe. You and me have gravitational force. Now, I've gone on dates before and they say, we just don't have any chemistry. It's not that. It's not that I don't have any chemistry. We all have gravitational force. It's just that the bigger the object is, like a moon or the earth, then you can feel the gravity, all right? But we have it, but it's so weak we can't even feel it. Not even help you with chemistry. So the strength depends on the size, the mass. Remember, the mass is the particles inside. The more particles inside, the more massive it is. And also, the greater the mass, the greater the gravitational force pulling. Now, gravity pulls only in one direction, pulls downward. All right. So if we can get more distance between planets, like if the moon were to move out just a little bit further, it wouldn't even be connected to us, would not be going around us, might be going around the sun instead, right? Less distance, the greater the force, right? And we use this formula, force is equal to mg. Force is, we can call newtons, is equal to the mass. Okay, we measure that in kilograms. And gravitational acceleration, so we measured this. We've dropped things off and we figured out, wow, gravity pulls on things and makes it accelerate 9.8 meters per second squared. So if we multiply those two together, we get a Newton, and that's what we call weight, right? So let's see if you remember which of these, what is mass? Because we had that in chemistry part of the physics class. Is it a force of gravity acting on an object, or is it the amount of matter in an object? I can tell you it isn't the last two. It isn't C and D, okay? It's either A or B. All right, we got three of you. All right, Kamaya is here. Good to see you, Kamaya. All right, so we've got Zaria and Shayana, and Kamaya is still to vote. We've got a whole 8 people. This is the smallest class I've ever seen, but I've got the most participation I've ever seen. 5, 6 people. Mariana made it. All right. So it's not the volume. Somebody said volume. I crossed this out. It's the amount of matter in an object. Okay, so if I were to draw a picture, so if I had this as my box, and then this is my other box. Let's see if I can make it the same size, about the same size. Is that about it? Okay, and I were to draw atoms inside, okay? Right, so let's say I've got 3, 6, 9 atoms inside this container. And let's say that's a solid. It only has 9 atoms, but it's usually not the case. And let's say I have only, in this one, I only have 5, okay? So this one is less, it has less mass. This one has more because there are more atoms in the same space. This one has less mass. And remember, it's the amount of matter. And again, I'm just using a visualization. Okay, this does not change. This does not change where I go from one place to place. Okay, the mass stays the same. So one thing always will have more matter than the other, right? So let's take a look at weight here. Okay. Hey, Mariana. I can help you during the last half hour of the class. Sure, Mariana. Yep, we're going to have a lot of time to work. Okay. All right. So what is weight then? Okay. Again, it's not volume or speed. Okay. Not volume or speed. It's either the force of gravity acting on an object or the amount of matter. Okay. All right. Did we get everybody in here? We got 5 out of 9. Lennon, Shayana, Joseph. All right. Ariana, you doing okay? All right. Okay, so we got 8 out of 9. Okay, and most of you said the force of gravity on an object. Okay, which is true. Force of gravity is how we measure weight, because you see what happens here. This pooch is in space somewhere and is floating around. He has no weight. Okay, so what is the relationship, would you say, between mass and weight? All right, it's not D and it's not A, it's B or C. Which do you think it is? Weight depends on location and mass does not, or mass depends on location and weight does not. Now, by location, we're talking about like being on the Earth or being on the moon. What do you think? Does your mass change by going to the moon? Or does your weight change by going to the moon? What do you think? Weight depends on location or mass does not? Mass depends on location, weight does not. Got 5. It's a little harder question, isn't it? How about you, Kamaya? Are you with me? I see your name, but I'm not seeing you making any votes here. Thanks, Mariana, Ariana, Joey, Zuria, Lennon, and Renaya. Thanks so much. And it is letter B, weight depends on the location. Okay, so again, you could be out in space where there's no masses big around you, and you could be weightless. Okay, you could also, if you put yourself on a scale, right, and you were weighing yourself, okay, and if you did that scale on an elevator going fast upwards, you would weigh more. You would be very heavy or heavier. And the other way, if you took a fast elevator down, then your weight would be smaller. Okay, so, and again, the further that you're away from the center of the Earth, your weight can change. And we're not talking about putting you on a diet. We're just talking about how gravity affects us, and that's all we have. All right, who else did we get in here? Anybody new? Bradley, good to see you. So let's see what you vote. Would you rather be on Earth and weigh 120 pounds or whatever your present weight is, or be on the moon and weigh with the weight of 20 pounds, 120 or 20? So there, see, the moon has less gravity and your mass doesn't change. So you are going to go in your whole, the whole business, you're going over there just as you are, but your weight's going to change, right? So by 2050, we hope to be on the moon and having research stations, building rockets from the moon because there's some water there on the moon. And you might be one of those people that would like to be there. So by 2050, maybe they'll have colonies on the moon. Now, you will always have to wear something outside of whatever your protective bubble is. And if you've ever seen some of the stories of during the 70s, 60s, and 70s where they took people to the moon and, they had to wear something to protect them from the cold, no oxygen, no air, and very little gravity. So they were able to jump quite a bit. All right, so only got some of you guys don't want to vote at all on that one, right? It's 5 people on here. Okay, so most of you said would rather be on the Earth. All right, so frictional forces are forces that resist the movement of objects and that contact their surroundings. So you think about it, you're walking through mud, right? It's harder to walk through mud. It's harder. You won't float away because there's gravity there, Joseph. There's just not enough gravity to hold any oxygen there, so you can't jump high enough to do that. But yeah, that's what they used to think. That would be a no gravity situation where you had no gravity. Then you would go on and on forever. But thanks for that question. So frictional forces, right? Guys stomping around. Yeah, even being on the moon is scary. I would not be the one going, that's for sure. You'd have to be braver than me, a lot braver. So, but friction also helps us with motion, right? Because I can push off on something else and continue to walk, right? So again, think about it as ice. Almost it has very little friction, and it's really hard to walk across the ice. You might be able to slide across the ice, but think about it in a situation where there's no friction, you can't even get anything going. Can't even get anything going. So friction does help us, but it does, you don't want to get to the point where it's holding you back so much that you can't even move. It depends. It's the materials that touch each other. They can be really sticky, they can be really slippery, and friction, you can feel the friction. You can create some heat in your hands by rubbing your hands together. So let's talk about what friction does. All right, so of these, what is friction? A force that pulls objects down? Nope, it's not that. That's gravity. The force that pushes objects forward, force that opposes motion, or a force that lifts it. So it's either B or C. B or C, which do you think it is? B or C? All right, and this is supposed to be a GIF of a pig on ice. It was not, it was sliding around. It couldn't get off of this slab to the grass. All right, we got 4 people. We're losing people left and right. People are giving up. Uh-oh. I do appreciate your participation, ladies and gentlemen. Somebody asked me why they have to participate. And again, like I said, it's one of those things. I try to keep you awake. You try to keep me awake, but also I need to know what you know. And that way I can make sure I go over certain things that people miss a lot. All right, so the force that opposes motion. Okay, it's always in the opposite direction. Always in the opposite direction. Now here is another frictional force, air resistance. Okay, and if you've ever seen meteor shower, well, meteor shower is rocks from space going through the air, and as they hit the air, they have a lot of speed and they burn up. They start to glow. All right, so air resistance is drag, friction when it comes to objects moving through the air molecules, slow us down. And we get to what they call terminal velocity. Now, terminal usually means dead. But in this particular case, terminal means it's not going faster and faster and faster. So if we didn't have any air, so what would happen, we're going about, at first second, we're going 10 meters per second. The second, we're going 20 meters per second, then 30 meters per second, then 40 meters per second. We go faster and faster and faster, but because of the drag, we can slow down to about 340 miles an hour going down. Okay, now with a parachute, we can slow down even more. We can increase the drag by adding a parachute here, slowing us down. Now, I had a friend, I shouldn't say a friend, an acquaintance that I used to work with in the 90s. He was a person that liked parachutes and jumping out of perfectly good planes, and his parachute failed. So he was able to use his body to maneuver around so that he came to a farmer's barn area, and there was a big pile of manure and hay. He hit that, broke almost all the bones in his body, but he survived. So terminal means that these forces of drag and gravity equal each other out, and we're not moving faster and faster and faster. Okay, then there's also centripetal force. This is the force that makes things turn in a path. Now, if you think about this, if you have your foot on this wheel here, right? And you've got your foot right here. This is making your foot go into a circular motion, right? Right. So that's what they call. So I always think about the pedal part as a pedal on and a gear, right? The direction is 90 degrees or orthogonal, which is a Greek word for 90 degrees at the time, and it points toward the middle, okay, going in a curved path. And then you've probably seen this when you've been on one of those um, playground, what do you want to call them, merry-go-rounds, right? Right, the playground merry-go-round, you get going faster and faster, and you can kind of feel yourself being pulled out. You have to hold on in the middle. So what is the centripetal force talking about? It's not C or D, right? Doesn't help us float, doesn't change color. What is it? Force that makes an object curve, or a force that pulls the object toward the center? All right, we're losing people again. Oh, thanks, Jasmine. Thanks, Joey. Thanks, Renaya. All right. Force that makes the object, let's do it again. Oh, I forgot here. Okay. Force that makes the object follow a curved path. All right, so tension, we've talked about tension before. You might get tension headaches, feels like, and usually it's resolved, when we're working on the computer, your neck and your shoulders, you're just not moving around enough and you're stuck in one position. But tension is transmitted through ropes and wires, and because it's forced by pulling on its end. Tension is upward, gravitational, and is downward. Equal forces if the load is hanging vertical. So you may be thinking of something that's being pulled up and a heavy weight, and there's strain on the cables, and they call that tension. And the spring scale is an example as well. You might have used a spring scale if you were fishing. You can put the fish on the line and see how much it weighs. Okay, so there's tension in that spring. And the last force we're talking about is the normal force. Now, normal is not what we think of when we talk about doing physics. Force that acts perpendicular to the surface and supports it. Well, I like to think of this normal force as a supportive force. So this book has a support force from the table of 10 newtons. The book is pushing down because of gravity 10 newtons and is staying put, right? If there was no supportive force, that you would break through the table, and if there was no supportive force on the floor, you'd break through the floor. So you would keep going down. So there's something that's supporting upward as well. So it's 90 degrees and perpendicular to the force. So let me ask you this question. What would you rather have? I would have a normal force standing on a top of a flagpole, or have no normal force jumping out of a plane, because you have nothing supporting you, pushing up on you, that supports you. But here, if you're standing on a flagpole, you have the flagpole holding on to you. Both those situations are high, in the air, scary to begin with. All right. All right. So we've got 5 people. Oh, wow. You guys are very adventurous. The flagpole. All right. So this last question about centripetal force. Okay. If you take a ride on the corkscrew, you're going to feel centripetal force, right? Would you rather take the corkscrew ride and feel that circular force that you're curving into a circular, or would you rather ride a roller coaster where there's no centripetal force? You just have the force of gravity that causes you to go up and down. Corkscrew or roller coaster? Corkscrew or roller coaster? All right, got those same 5 people. All right, so most of you would rather do the roller coaster. Me too. I get worried about the so here is an exit quiz we're going to do, and then I'm going to call her done. We got about 5 more minutes, and then we'll open up a big blue button to help people that need some help with some assignments, okay? So here is this. Hey, Anaya, how are you? Okay, so this is a Kahoot exit quiz. Let me start this for you guys. There's your link. Go to the chat here. There's the link to the Kahoot. Let me cause this to pause. Okay, so what we're going to do today, ladies and gentlemen, all right, I'm going to open up Big Blue Button. So Big Blue Button here in a minute. So there's not that many of you if you want to come in and talk to me, but I can tell you quite a few people have not done the assignments from last week. Now, probably most of you in our class have, but if you have something that you need to work on, I know that of the 54 people, probably only 20 people have done all of week 4. All right, so week 4-1, week 4-2, and the quiz, that was 90 points. So if you guys will get ahead, go ahead and do that. If you need some questions on anything other than the test or a quiz, I'm sure here to help you. All right, so I'm going to put this on pause.